Okay, hello. Sampling and populations with your favorite capture, recapture technique, and whatever else is in this topic. Alright. We're going to delete all this from a previous tutorial. Sorry, it's hard to take this seriously. Okay, so which of the following is an example of a sample? Now remember, a sample means you ain't taken everyone, just a part. Voting at the federal election, unfortunately that's compulsory, so I think everyone has to do it. Year 12 students in the HSC, that's like all of them. 50 shoppers whose names are drawn from a box. That's a sample, okay? The opinion of every student in your school on the on the latest movie. What do you think of Ghostbusters? I've heard Ghostbusters is awful, the new one. I don't know why they're doing it. Okay, so this one's a sample. The other ones are populations, because it's everyone of a certain description. Okay, so C. Alright, the table below shows the heights of 5. Oh my god, they're so tall. Population mean. So just find the average, okay? We just add them in whatever. It's obviously not 915. It's not. In fact, it has to be 183. But look, let's calculate it anyway. It keeps doing this, so we're going to do 183 plus 189 plus 177 plus 186 plus 180 divided by 5. There may actually be a shortcut, but let's just do it. Hang on, why is this so big? 183 plus 189. In fact, I bet it's going to be that number. Yeah, 915. Okay, yeah, 183. Alright, that's the mean. You add them up, divide by how many there are. A sample of 3 players is taken. How many samples? Okay, so this is sort of probability or combinations. There's 5 people. We're choosing 3. So on your calculator, it's 5 choose 3. 5C3, which I'm pretty sure is 10. Yeah, you can also list them. Okay, AB, AC, AD, AE, BC, BD, BE, CD, CE, DE. There'll be 10 of them. Alright? Alright, to determine the number of rabbits. Ah, my favorite. Okay, so there are 960 definitely tagged. Okay, I like thinking of it as a ratio. So 420 compared to 168 is sort of the ratio of how many there actually are compared to the tagged. Okay, that's the ratio. If we times that by, we know there's exactly 960 that are actually tagged. That should estimate the population. Okay, I don't know if you want to write like a P for that. It's just an estimate though. So 420 over 168 times 960, 2,400. Okay, and again, I just encourage you, keep pausing this. I'm trying to go really quickly so the video is not too long. You pause it as much as you want. Oh, okay, so C. Alright, expression caption tag. Okay, same thing. He later captured 150 and found 40 of them were tagged, so the ratio is 150 over 40, and then times that by 200. So let's do the exact same thing. Bit of consistency, 150 over 40. Okay, the order doesn't matter as long as you're timesing and dividing by the right numbers. Okay, 750. Cool. Alright. D. It's false. I love when they say that. That's really confusing. Which one is false? So there's 3 that are true. That's not random. I think that one's false. They should all have an equal chance. Yes, they can be use a table, calculator, or spreadsheet. That seems a bit subjective, but I guess yeah, for small populations, a random sample is easy. What? What? Well, I don't know what that sample size that represents the population ensures. I don't know what they mean. Ensures. I don't know how that ensures it's accurate. Yeah, I don't know. Maybe they mean if you've got a big population, you can't sample 50 people to represent Australia, because Australia's got millions. You'd need, I don't know, like several hundred or 1,000 to have a reasonable representation, and it needs to be random. Anyway, I'd say A. I don't know. It's very important. With a random selection, they should all have an equal chance of selection. Alright. Okay, this one's easy. Population is everyone. A sample is only a smaller group. For example, if you took every student from Sarah Redfern High School, that's a population. But if you took 30 students at random, that's a sample. Has to be random. Another example, if you took a census for all of Australia, everyone answered a survey, that's a population. But if you took randomly only 3% of people, or 0.1% of the population in Australia, that's a sample. Alright. Part-time. Okay, again, I don't know if I can do standard deviation. You just need to put these numbers into your calculator and get it to calculate it for you. I'll try to show you that. We'll practice that in class, or I'll make a video if I get a chance. But the mean is easy, you just add them. So that'd be, I'll just write it out. So, and then divide by 4. But again, your calculator can do that. The statistics thing. That's 2749 to 64. Oh, sorry. Divided by 4. I got 16. Okay. Hopefully that's right. Yeah, actually I can tell that's right. Okay. 2 are chosen. So if there's 4 and you're choosing 2, so on your on your calculator, if you do 4 choose 2, you get 6. But JKLM, it's just going to be I guess this is a picture of them. It's hilarious. You could have JK, JL, KJM, KL, KM, LM. I'm trying to be systematic, but yeah, there's 6 of them. Okay. Let's see. The sample mean. Okay, Jake and Kira. Where are they? Jake and Kira. I don't even know what the standard deviation is when you got 2 people. But the mean is going to be in the middle. 37, 18.5. So for JK, makes me think of JK Rowling. So the mean is going to be 15 plus 7, 22 over 2 or whatever. So 18.5. Okay, the standard deviation, I don't know. Just you'll have to put them in your calculator and get it to find it. If I had to estimate, let's say 3 or 2 point something, it's hard to tell. Okay, sample size 3 is chosen. This actually seems easier. So for that, again, you can use your calculator. 4C3 will be just 4. Okay, it's really a matter of who you leave out. So you could have JKL. Why am I doing it like this? JKL, JKM, JLM, KLM. In each case, just one person gets left out. Alright. Calculate the sample mean. Jake, Lola, Marcus. Leaving Kira out. Poor Kira. Then, okay, the mean would be 15 plus 10 plus 17. And you have to divide that by 3. So I'd get 14. Okay? Again, sample standard deviation, you have to use your calculator. And one thing I should really emphasize though, it says sample. So on your calculator you'll get options of this one, and you'll also get this one. So this is population, whatever. I'm just doing this really roughly. They're both standard deviation, but this is for a population, this is for a sample. This is, to be honest, I think this is a really stupid example. Because this is not a population, this is just 4 people randomly, okay? You can't call them a population, it's silly. But it does say population standard deviation. So for the first one, make sure it's this one. But for the next, these ones, it's a sample. Make sure it's SX. It's meant to work a bit differently. Alright. Okay, 2 people from 5. This is just 5C2. Keyword I think is, it says taken. I'm thinking of chosen. But it's the same thing. You're taking them, you're choosing them. 5C2, which again I think was 10. Yeah. Okay, it's the same as choosing 3. It's the same thing really. If you've got 5 people and you need to pick 2, you're really picking 3 as well. You're just dividing it into 2 groups, 2 and 3. Alright. She randomly, just one day, she just randomly captures these sharks. She's just crazy. Okay, so the ratio is 14 to 6. Exact same thing. In fact, I'm just gonna get rid of all of that and just gonna change the numbers. So 14 compared to 6, times that by 36. Okay, there are different ways of thinking of it, but okay, 14 over 6 times 36, 84. So, and again, it doesn't have to be a whole number. Honestly, I don't think it matters. I would just round off. You don't need to round up or round down. It doesn't matter. So 84. It's just an estimate. I would round to the nearest number. So 84 sharks is our estimate. Okay. It's another question of the same kind. So I'm gonna copy this. Okay. 120 out of the 120, 50 found to have tags, so that's our ratio. Times that by the actual number that are tagged. 120 over 50 times 220. 5280. And just to maybe wait. Did I think I typed it wrong. Oh, yeah, I left out the 50. I was going to say, this number's not right. 528. Okay, to understand it a bit better, when he captures those 120 and finds 50 are tagged, just think of it, that means a little bit less than half are tagged. But whatever, so if out of 50 random ones that are tagged, that was out of 120. So that tells you the ratio. It's about twice as many as however many are tagged. So if we know for a fact that there are exactly 220 tagged, hopefully there's not another scientist doing the same thing at the same time who hasn't told you that they're also tagging, because that'll mess up your numbers. But you times that by that ratio, 2 and a bit. See how that's a bit less than half of the total, 528. Alright, same thing again. Oh boy. We get it. They're exactly the same. The formula's the same. It doesn't change. Alright. I love that. We don't need to know about that. Okay, 1050 were caught, of which 105 were tagged, and then times that by how many actually were. Actually, I can do that easy peasy. Pretty sure that's 15,000. Okay. Doctor saw 8. This is confusing. What? Okay, so I guess he's sort of tagging them and saying, I recognize you from a specific day. So we're guessing proportion. Yeah, I think it's the same thing. I'm just finding it confusing. I'm wondering if it really does make logical sense. Think of it as, okay, it's just Okay, 8 people randomly that he remembers as, okay, they have cancer, I know that. Now, randomly, he sees, I'm guessing these patients have cancer, 35, wait, I'm just going to put the numbers in and then think about it. But yeah, so the 35 later, okay, including 7, it's about a fifth. So my estimate was 40. For some reason that one I find confusing. Maybe it makes sense to you, but it's like, okay, so 8 he knows has cancer. And he saw them on a specific day. And then if you take 35 random, are these all cancer patients? They're just random patients. I actually have to think about that. I'm going to think about that later. Okay. What is this? Oh, okay, it's generated ran between. Okay, so random numbers from row 4. Okay. Sample mean. What? A random sample. Okay, so I think what they're asking is what is the mean of these numbers here? So I don't know if I'm going to bother doing this. You'll just need to add these numbers 1, 2. I don't know why it shows the zeros. It really seems silly. It shouldn't show those zeros. In my opinion, it makes it look silly. But you would add those up to from A to J, to D, 4, 5, 6, 7, 8, 9, 10, and divide by 10. Rows 4 and 5. So again, you would just add those up and divide by 20. 4, 5, 6, you'd add those up and divide by 30. Yep, and this is a pattern that should happen. Whatever the population mean is, right, over time as you take more and more, the sample mean should get closer and closer. It should start to get closer to the population mean. I don't think this is the best example because it's random numbers. You want to pick more meaningful data. Alright, I was just thinking I actually have access to the answers for these though as well. I don't need them for this, but maybe for other topics. Alright, anyway, I hope that helped. I think this is a pretty small topic. Maybe I'll just try to also remind you, where was it? Okay, maybe I'm thinking of a different topic. But yeah, this C thing is important. Like this idea, if you've got these choices, how many ways to select 2 people? So you can do 4, choose 2. Which is a button on your calculator, or write it out. Okay, look, I'm going to leave it there. Thanks for watching. Hope you learned something.